read the question. So this sentence is something will trouble student at your level. What is the RMS voltage per unit length of this induced EMF? Why is saying noise? I think I gave in the AC circuit, I think something weird. So when you rotate a loop in a magnetic field, we'll get an EMF induced, no? And what actually happens? We get signals of this kind. Next will be E naught by select a E naught by 2 sine 3 omega t plus some phase angle. Next some E naught by 4 sine 5 omega t plus some phase angle. E naught by 8. And need not even it can have 4 omega, like a 6 omega also. I'm just giving that one. This is the fundamental. This is a fundamental. This is what needed. These are all unwanted. These are called harmonics. Can you remember? In AC circuits, we have discussed here. When you rotate a loop in a magnetic field, what we are thinking is only this generated, but practical open, all these harmonics are generated. Okay, I think we have to go to a little bit higher level to give this explanation for why harmonics are generated. It's not there for our syllabus. Okay, we'll just have an idea. This one. So this is fine. This is the requirement. These things will lead to noise. These are unwanted things. All these are unwanted things. There's a big headache here, that one. So not only this, everywhere, where all AC signal comes, no, where you're generating a signal, no, these are unwanted. So your entire circuit designing, this is very easy to generate. This is the most difficult thing. Okay, that's what it is saying. The conductor induces noise in a telephone circuit. Not only this, even this also. What is the RMS voltage per unit length of this induced EMF? So, but is again is asking, since he said noise, no, this is unwanted. He's asking again the RMS value of this one. I think you have to be RMS value of this, and all these are unwanted. So will you calculate all? No, this is unwanted, so don't bother. So even this is what needed. So he's asking only this much again, because it'll be very like a saying noise, but he's asking RMS voltage means he's asking only of fundamental, not of total signal. But practically what happens if I design a circuit, I should calculate RMS of this total signal. So we'll try to avoid mathematics. So I'm just taking out this one, unwanted noise. Or else you should have avoided that sentence. So straight away what happened, we would have thought only this much. So the noise means you mean to say this one. So JEE Advanced, he may ask like any of conceptual way of question rather than mathematics. No, he may test with conceptual. It's a part of syllabus just only, but will not go for any maths involved in this one. So you say like, what is the RMS voltage per unit length of this induced EMF? Now, first question you have to answer, where is a loop? We are not saying a loop. Is saying RMS voltage per unit length. So I think that that particular sentence is enough. No, if this is the one wire, these are the two wires, and this is the current carrying wire. The current in this is varying the same diagram. So this is D1 and this distance is D2. So shall we assume a strip here? We'll assume a small strip. It's a long, it is understood it's a long, so write it infinity here. This one. So let this distance be dx. Let it be at a distance 6. I think this is what happens in exam, no? So you will not give information properly. Even in advance, it happens. Students like every year it's happening that 2-3 questions will happen. They should have given information more. So due to language or something, no, we don't get idea. Let's get into the, I think how to calculate the flux linking this. So d phi. B into, say, like a L into dx. So as it is now, directly the B bar will be out of the plane here. So mu naught I or if you want, okay, let it be this much only. Mu naught IL 2 pi dx by x. So this should be equal to from d1 to d2. L is what I'm assuming. So later on I'll make it flux per unit length, because what is asking now? The EMF induced per unit length. So flux linking per unit length. So this is, if you want to write it L, you differentiate this. Okay, this is further. I is equal to I naught sine omega t log of d2 by d1. So let's differentiate this. So this will become EMF per unit length. Something let me call E dash RMS value of this. So I think we should get the maximum value of this. So this should be equal to E dash equal to mu naught I naught omega 2 pi log of d2 by d1 cos omega t. So this is what you're going to call it as E naught. So what is RMS value? Per unit length, actually it is E naught by root 2. 2 root 2 pi
2 microvolt.
2 microvolt per meter.
Sure.
Yeah. Yes, sir.
So actually what we do is, so how to bring that per unit length? Go back to magnetism, no? Force experience per unit length, like this EMF induced per unit length also can come into picture.